Rockhounds presented by the Danbury Public Library. My name is Darcy, and each month I'd like to introduce you to various places in our area where we can hunt for and learn about interesting rocks. We live in an amazing state. Not only do we have a number of state parks to enjoy, we have a rich geological history to explore. To learn more about this, I took a trip down Route 7 to a special set of museums in Kent that I can't wait to share with you. But before I do, let's review our rules that all rockhounds should know and follow. Rule number 1, we never go into the woods or strange places alone. Rule number 2, we do not go on private land without permission. Rule number 3, we do not litter and we clean up any litter we find, even if it's not ours. Rule number 4, we only take a few rocks. We leave some behind for others to find. And rule number 5, we do not remove rocks from national and state parks. It's illegal to do so. Now that we've reviewed our rules, let's start this month's adventure. Today we're heading down to the Connecticut Museum of Mining and Mineral Science. It's about a 15-minute drive down Route 7 from Danbury, just a little past the city of Kent. Now, last time we got together, we explored Mine Hill Preserve. You remember that? Do you remember that big furnace we saw? Well, near the museum, you can see the remains of the Kent iron furnace. This 30-foot tall furnace ran for nearly 70 years, from 1825 to 1892. The ore that was mined and processed at Kent was of a very high quality, around 60% iron. This made the mining operation at Kent very profitable. Iron from Kent helped meet the metal demands of the Civil War. After the Civil War ended, the iron went towards the growing train industry, as well as to create engines and pumps that were made down in New Jersey. While the area around the furnace is covered in trees today, when the furnace was up and running, the landscape would have looked completely different. The reason is that one of the ingredients needed to process iron is charcoal, which is made from trees, and the furnace needed a lot of it. It took around 138 bushels of charcoal, 2,612 pounds of ore, and 432 pounds of limestone flux to make a single ton of pig iron. Barring times that when the water supply was frozen over during the winter, or too low in the summer, or the furnace had to be shut down to make repairs, the iron works ran for 24 hours a day, 7 days a week. It's said that in 1870, the furnace at Kent was producing around 50 tons of pig iron per week. So if we take the amounts needed to create 1 ton of pig iron and multiply them by 50 to get 50 tons, we see that at its peak, the furnace chewed through 6,900 bushels of charcoal, 130,600 pounds of ore, and 21,600 pounds of limestone flux each week. Wow! So as you can guess, in order to get all that charcoal and all that ore and all that limestone, it would have made the landscape look very different. There would have been no trees because they all would have been cut down for the charcoal, and the area would have been dug up to find the ore and the limestone. But the remains of the furnace isn't all that's left. If you look around on the ground, you may see some slag. These are impurities that were once contained in the iron ore. That's, once it was melted down, was mixed with ash and bits of that limestone flux. They're what's left behind by the iron-making process and can be found in different colors. We saw slag that had hints of green, blue, and even purple in sunlight. Once you've explored the furnace, it's time to head into the museum itself. There's so much to see here, and if you're a fan of rocks and geology like I am, it's easy to spend hours poking around and learning. There are even areas that let you experience what being in a mine would have been like. Spoiler, it's very dark and loud.
So anything, but I have no problem with the process as long as we get the scrubbers.
Large dioramas give us an idea of what some of the various iron furnaces would have looked like during their operation, as well as a look at the main ores that can be found in our state, and the various materials needed to get that iron ore into pig iron. Hands-on exhibits let you feel just how much some of these minerals weigh. The density of galena was really surprising. I couldn't even pick it up. But Connecticut wasn't just known for its minerals and mining. Thanks to the effects of Ice Age glaciers in the past, we have a number of rich clay deposits throughout the state, perfect for making bricks. There used to be over 200 brick-making companies here in Connecticut, each with their own stamp that identified their bricks from others. You can see a number of these brick molds at the museum, as well as an old hand-crank brick press. Look under your feet while in the brick exhibit to see some more of the bricks from local makers. The next museum over is the Eric Sloan Museum, which houses an amazing collection of antique tools, including this dog mill that was used to churn butter. Can you guess what some of the items shown here were used for? Like these giant rakes. What do you think they were for? Or how about this machine? And what could be done with this, do you think? Outside is a full replica of a cabin based on the book The Diary of an Early American Boy, 1805, that Eric Sloan illustrated. You can walk inside and experience what houses would have been like way back then. It's really cool. Now, I bet you noticed these strange looking things at the mining museum. No, they're not photoshopped, nor are they fake rocks on a TV screen. They really look like that. These are fluorescent minerals. They're sometimes called glow rocks because they glow or fluoresce under a special light. But why does this happen? All minerals can reflect light. This is what makes us able to see them. You see, light is made up of multiple colors. If we run white light through a prism, we see a rainbow. The prism has broken the white light into its individual colors so we can see them. This is actually how we get rainbows in the sky. Water vapor and moisture in the air acts as a prism, and it causes the white light, when it hits that, to refract and go into all those various colors that we see. So that's pretty cool, huh? But thing is, it gets even cooler. When we look at this apple, it looks red to us, right? Thing is, the apple itself doesn't actually have a color. What's happening here is that all the white light around us is hitting that apple, and the apple is absorbing most of that light. The red part of the light is being reflected back at us for our eyes to see, and this is why the apple looks red. So, all rocks and minerals reflect light, but some can actually absorb a small amount of light and reflect it back at a different wavelength or color than what we normally see. Ultraviolet light in a dark room can help us see these different colors more easily. So to understand how this works, we need to realize that everything is made up of atoms, even minerals. These atoms, meanwhile, are made up of protons, which have a positive charge, neutrons, which are neutrally charged, and electrons, which are negatively charged. The protons and the neutrons make up the nucleus or center of the atom, while the electrons buzz around in an orbit outside the nucleus. The ultraviolet light excites the electrons in the atoms of certain minerals. Kind of like what happens if we eat too much sugar. We get really hyper, right? Well, that's what the electrons are doing. They're getting all hyper and excited by that ultraviolet light. When the electrons calm down, they drop back down to where they were before in the orbit. And when this happens, they release some of that stored up energy as photons of light. It's these photons at a different wavelength than the mineral usually reflects that gives us those bright colors and that glow. The thing is, not all minerals do this. Only around 15% have a fluorescence or glow that we can actually see. Even then, not all the mineral samples found in that 15% will glow. Some just won't do anything. This glow usually happens when special impurities called activators are found in that mineral. And the thing is, it gets even cooler still. If a mineral continues to glow for a bit after the ultraviolet light is turned off, then that mineral is said to be phosphorescent. Meanwhile, minerals that glow when they are heated are said to be thermoluminescent. It's really neat, huh? Thank you for joining me this week as we explore the Connecticut Museum of Mining and Mineral Science and the Eric Sloan Museum. If you're curious about checking out these museums yourself, they're open Saturday and Sunday from 10 a.m. to 4 p.m. There's a lot more to see than what I can show you in the short amount of time we have together. In fact, there's so much to see that I know I missed some things myself, and I'm looking forward to going back and seeing and exploring again. Maybe I'll see you there. Tune in next time as we explore another area and look for more interesting rock finds. Until then, stay safe and stay curious. Bye, everyone.